Everyone. Today we're going to be doing exercise 2.4 of chapter Polynomials in NCERT Class 9 Mathematics. So let's get right to it. Question number 1 of the exercise is asking us to determine which of the following polynomials has x plus 1 as a factor. So the first part of this question is the polynomial x cube plus x square plus x plus 1. Now we need to check whether x plus 1 is a factor of this polynomial. So let me call this polynomial as p of x. The divisor in this case is x plus 1. Taking the 0 of this divider, I get x equal to minus 1, and therefore through the factor theorem I'm going to try and calculate p of minus 1 and see if it is equal to 0. This becomes minus 1 whole cube plus minus 1 square plus minus 1 plus 1. This becomes minus 1 plus 1 minus 1 plus 1. The terms cancel themselves out and we're left with 0. Now since p of minus 1 is equal to 0, through the factor theorem we can say that x plus 1 is a factor of this polynomial. The second part of this question is x to the power 4 plus x cube plus x square plus x plus 1. Now I'll call this polynomial p of x. Again, since we need to check whether x plus 1 is a factor, the 0 of this is x equal to minus 1, and hence we're going to calculate p of minus 1 for this case. So this becomes minus 1 to the power 4 plus minus 1 cube plus minus 1 square is minus 1 plus 1. This becomes 1 minus 1 plus 1 minus 1 plus 1. Here we're left with the number 1. Since the remainder is not equal to 0, we can say that x plus 1 is not a factor of this polynomial. The third part is x to the power 4 plus 3x cube plus 3x square plus x plus 1. Here again, in order to check whether x plus 1 is a factor of this given polynomial, we'll calculate the value at p of minus 1 and we'll check whether the remainder is 0. So here we've replaced x with minus 1 in the polynomial. This gives us 1 minus 3 plus 3 minus 1 plus 1. Here again we're left with a remainder of 1, which means that x plus 1 is not a factor of the given polynomial. The fourth part is the polynomial x cube minus x square The fourth part of this question is the polynomial x cube minus x square minus 2 plus root 2 whole into x plus root 2. That is x cube minus x square minus 2 plus under root 2 of x plus under root 2. This is the given polynomial. Again, to check whether x plus 1 is a factor, we'll take out p of minus 1 which in this case would be minus 1 whole cube minus of minus 1 square minus of 2 plus under root 2 into minus 1 plus under root 2. This will result in minus 1 minus 1 again. The minus and minus will change the sign over here, so this will become 2 plus root 2 plus root 2 again. And ultimately, the two minus 1s get cut off with the plus 2, and this will give me 2 times root 2 as the remainder. Since this is not equal to 0, we can say that x plus 1 is not a factor of the given polynomial. And that completes question number 1 for us. Moving to question number 2, it's asking us to use the factor theorem to determine whether g of x is a factor of p of x in each of the following cases. So moving to the first part, p of x in this case is 2x cube plus x square minus 2x minus 1. It's 2x cube plus x square minus 2x minus 1, while g of x in this question is x plus 1. So now, just like in the previous question, we're going to use factor theorem, and in order to use factor theorem, we're going to equate g of x to 0, so that makes x plus 1 equal to 0, or x is equal to minus 1. We'll replace this value of x in p of x, the polynomial given to us there, and we're going to check whether this is equal to 0 or not. Minus 1 square minus 2 into minus 1 minus 1. So this gives us minus 2 plus 1 plus 2 minus 1. The terms cancel each other out, and p of minus 1 is equal to 0. So this means that g of x, which is x plus 1, is a factor of p of x given in the question. Now in the second part, we have p of x is equal to x cube plus 3x square plus 3x plus 1, while we have g of x is equal to x plus 2. Just like in the previous question, we'll equate g of x to 0, and we'll get x as minus 2. Now replacing this value of x in p of x, so we get p of minus 2 is equal to minus 2 cube plus 3 into minus 2 square plus 3 into minus 2 plus 1. This gives us minus 8 plus 12 minus 6 plus 1. This will be 13 minus 14, which is equal to minus 1. So since p of minus 2 is not equal to 0, we can say that g of x is not a factor of p of x. The third part of this question has the polynomial p of x equal to x cube minus 4x square plus x plus 6, while g of x is given as x minus 3. Just like in the previous questions, we'll equate g of x to 0. This gives us x equal to plus 3. Now to check using factor theorem, we'll substitute 3 in the polynomial p of x, giving us p of 3 is 3 cube minus 4 into 3 square plus 3 plus 6. This gives us 27 minus 9 fours are 36 plus 3 plus 6. This gives us 36 minus 36, which is equal to 0. So in this case, since p of 3 is equal to 0, by factor theorem we can say that g of x is a factor of p of x. Now moving on to the third question. The third question asks us to find the value of k if x minus 1 is a factor of p of x in each of the following cases. And the first one over here is p of x is equal to x square plus x plus k. Now, we've been told that x minus 1 is a factor of p of x, which means that when I equate x minus 1 is equal to 0, giving me x equal to 1, p of 1 should be equal to 0 according to factor theorem. So if I try and calculate p of 1, I get 1 square plus 1 plus k is equal to 0, giving me 2 plus k is equal to 0, or k is equal to minus 2. And that's the value of k for the first part. Now the second part says p of x is equal to 2x square plus k of x plus root 2. Now again, using factor theorem, we know that if x minus 1 is a factor of this polynomial, the value of p of 1 should be equal to 0. And the value of p of 1 would be 2 into 1 square plus k into 1 plus root 2. And we can equate this to 0. This gives us 2 plus k plus root 2 is equal to 0. K is equal to minus 2 minus root 2. That's the value of k for the second part. In the third part, we have p of x is equal to k into x square minus root 2x plus 1. Again, in order to find the value of k, we know that p of 1 should be equal to 0 since x minus 1 is a factor, and this gives us k into 1 square minus root 2 into 1 plus 1 is equal to 0. That gives us k minus root 2 plus 1 is equal to 0, and hence the value of k becomes root 2 minus 1. And through factor theorem, that's how we get the value of k. Now the fourth part is p of x equals k into x square minus 3x plus k. Again, we know that x minus 1 is a factor, so p of 1 must be equal to 0. This gives us k into 1 square minus 3 into 1 plus k is equal to 0. This results in k minus 3 plus k is equal to 0. This gives us 2k is equal to 3, or k is equal to 3 by 2. That's the solution for the fourth part. This brings us to the end of question number 3. Now the fourth question is asking us to factorize the given polynomials. The first part here is 12x square minus 7x plus 1. Now in order to factorize this polynomial, we'll use the method of splitting the middle term. Now in any quadratic polynomial of the form ax square plus bx plus c, in order to split the middle term plus bx, we need to make sure that we split it with the coefficients multiplying to a into c, right? In this case, it will be 12 into 1, which is equal to 12. And hence, to split the middle term, we can split it in the product of minus 4 and minus 3, which is equal to plus 12. So by that logic, we can write this as 12x square minus 4x minus 3x plus 1. From the first two terms, I can take 4x common, leaving me with 3x minus 1. In the in the third and fourth terms, I will take minus 1 common and be left with 3x minus 1. Again, taking 3x minus 1 common from this equation, I get 3x minus 1 into 4x minus 1, and we have factorized this polynomial thus. The second part to question number 4 is 2x square plus 7x plus 3. Now here we'll try and split the middle term again. However, we need to split 7x in such a way that the coefficients that we get multiply to 2 into 3, which is 6. Now, what two terms can we take that will multiply to get 6 but will add up to get 7? The two numbers in this case would be 6 and 1. So therefore we can write this as 2x square plus 6x plus x plus 3. Over here I can take 2x common from the first two terms. I get x plus 3. Second one is x plus 3 into plus 1. So here I will get 2x plus 1 multiplied by x plus 3, and that's how we factorize the second part. The third part is 6x square plus 5x minus 6. Now in order to factorize this polynomial, we need to split the middle term 5x in such a way with two numbers that add up to 5, and the product of the two numbers would be the same as the product of 6 into minus 6. 6 into minus 6 gives me minus 36. Now I need to think of two numbers that will multiply to get minus 36, but when I add them, I get plus 5. And two such numbers are 9x minus 4x. 9 into minus 4 also give us minus 36. So hence we can split this middle term as 6x square plus 9x minus 4x minus 6. We take 3x common from the first two terms and we get 2x plus 3. We'll take minus 2 common from the next two terms, and we again get 2x plus 3. This will then become 2x plus 3 multiplied by 3x minus 2, and that's how we factorize the third part. The fourth part of this question is the polynomial 3x square minus x minus 4. Now here we'll split the middle terms in such a way that the product becomes 3 into minus 4, which is minus 12, and the sum of the middle terms is minus 1. So these are the numbers minus 4 and 3 itself. So here we can write this as 3x square plus 3x minus 4x minus 4. Taking 3x common from the first two terms, I get x plus 1. Taking minus 4 common from the next two terms, I get x plus 1 again. This gives me 3x minus 4 into x plus 1. That's how we factorize the fourth part. Now question number 5 of this exercise is also asking us to factorize the following polynomials. However, in this case we have 4 cubic polynomials. So let's see how we do that with the help of factor theorem. In the first case, we have x cube minus 2x square minus x plus 2. So over here, what we're going to take is the last term 2 over here, and we're going to try and see what are the possible factors that can lead to a product of plus 2. So these will be plus minus 1 and plus minus 2. What we're going to do is we're going to do a hit and trial, and we're going to see if any of these 4 numbers can be used to replace x and get a value of 0. And through factor theorem, we can then find one of the factors. So let this be p of x. Let me try for plus 1 first. P of plus 1 is 1 cube minus 2 into 1 square minus 1 plus 2. This gives me 1 minus 2 minus 1 plus 2. The terms cancel each other out, and I get p of 1 is equal to 0. Now through factor theorem, I know if p of 1 is equal to 0, in this case, x minus 1 must be a factor of the given polynomial. Further, I can check for other factors as well. So let me check for p of minus 1. When I take p of minus 1, I get minus 1 cube minus 2 into minus 1 square minus of minus 1 plus 2. This gives me minus 1 minus 2 plus 1 plus 2. Here the terms cancel each other out again, and so if p of minus 1 is equal to 0, x plus 1 is surely a factor. Case number 3 we can take is calculating p of 2. Here p of 2 will be equal to 2 cube minus 2 into 2 square minus 2 plus 2. Here the terms again cancel each other out, giving p of 2 equal to 0, indicating that x minus 2 is a factor. So if I were to factorize this, I know x minus 1 is a factor, I know x plus 1 is a factor, and I know x minus 2 is a factor. the product of these three terms will give me the given polynomial, and hence this is the factorization of p of x. Now, the second part of question 5 is x cube minus 3x square minus 9x minus 5. Let's call this polynomial p of x. Now the last term here again, which is minus 5, all possible factors of minus 5 are plus minus 1 and plus minus 5. And so what we can do is check for each one of them. So in case plus 1 could be a factor, I will check for p of plus 1. This gives me 1 cube minus 3 into 1 square minus 9 into 1 minus 5. This is 1 minus 3 minus 9 minus 5, which will be minus 16. Now since p of 1 is not equal to 0, we know that x minus 1 will not be a factor. And the second one then that we can check is p of minus 1. P of minus 1 will give us minus 1 cube minus of 3 into minus 1 square minus 9 into minus 1 minus 5. This gives us minus 1 minus 3 plus 9 minus 5. The negative terms add up to minus 9 plus 9. These terms cancel each other out, giving 0. And this implies that x plus 1 is a factor. Here we'll check for the other two cases as well. We'll check whether p of 5 is a factor. This is 5 cube minus 3 into 5 square minus 9 times 5 minus 5. This is 125 minus 75 minus 45 minus 5. The negative terms over here add up to minus 125. They will cancel each other out, and we get p of 5 is equal to 0, implying that x minus 5 is a factor. Now for the last possible scenario, we'll also check if p of minus 5 is equal to 0. So this gives us minus 5 cube minus 3 into minus 5 square minus 9 times minus 5 minus 5. This is equal to minus 125 minus 75 plus 9 5s are 45 minus 5. Here the negative terms add up to minus 205 plus 45 which is equal to minus 160, not equal to 0. So this means that out of all the possible ones, we found two of the factors, which is x plus 1 and x minus 5. Now, in order to find the third factor, we need to do a bit more effort. So we have x plus 1 into x minus 5 multiplied by another, let's say, q of x is equal to p of x. Now this term is equal to x square plus x minus 5x minus 5 into q of x equals p of x, which is nothing but x square minus 4x minus 5 times q of x is equal to p of x, which over here is x cube minus 3x square minus 9x minus 5. Now this means that if we use the long division method to divide our p of x by the terms that we got here, we will find q of x. Now I won't be showing the long division in this question over here. However, if we do it, we will find that q of x comes out to be x into plus 1. And therefore, the factorization of given p of x would be x plus 1 into x plus 1 into x minus 5. That's the factorization of the second part. The third part is the polynomial x cube plus 13x square plus 32x plus 20. Now here in the final constant term 20, this can have multiple factors, and I'll list them down over here. We have plus minus 1, we have plus minus 2, we have plus minus 5, we have plus minus 4, plus minus 10, plus minus 20. Now factorizing this would initially involve a lot of hit and trials using these. So what we can do over here is, let's start with the first one, which is p of 1. P of 1 will be 1 cube plus 13 into 1 square plus 32 into 1 plus 20. This comprises of all positive terms. I know this will not be equal to 0, so I know that p of 1, or rather x minus 1, is not a factor of the given polynomial. Taking p of minus 1 on the other hand, we get minus 1 cube plus 13 into minus 1 square plus 32 into minus 1 plus 20. This is minus 1 plus 13 minus 32 plus 20. This gives me plus 33 minus 33. They cancel each other out, giving me 0. And since p of minus 1 is equal to 0, we can say that x plus 1 is a factor of this polynomial. Now, One way to go about this is using the same hit and trial method for the other factors and trying to determine if any of them come out to be equal to 0, and then through factor theorem we can say that one of them will be a factor. But a shorter way to do that would be dividing this polynomial by one of the factors that we have, x plus 1, and getting the resultant polynomial. And I'm going to show you how that's going to help us. So again, I'm not going to show you the long division when I divide x plus 1 by the polynomial given in the question, but the resultant output is x square plus 12x plus 20. And now that we've got this equation through long division, we can use the splitting middle term to factorize this quadratic equation and get our solution. So in order to factorize this and split the middle term, I need to find two middle terms such that the product is 20 and the sum of the two terms is 12. If you've guessed 10 and 2, you're absolutely right. So what we will get here is x plus 1. So we're going to split the middle term as 10x plus 2x over here. This is going to help us factorize. This becomes x plus 1 into, taking x common here, we get x plus 10. Taking plus 2 common, we get x plus 10 here again. And this gives us x plus 1 into x plus 2 into x plus 10. And that's how we factorize the third part. The next equation is 2y cube plus y square minus 2y minus 1. Now in order to solve this fourth part, let's call this polynomial p of y. We're going to check for our usual suspects, so which is p of minus 1. This is 2 into minus 1 cube plus minus 1 square minus 2 into minus 1 minus 1. This gives me minus 2 plus 1 plus 2 minus 1. This becomes equal to 0, implying that y plus 1 is a factor. I'll also check for p of 1, which becomes 2 into y cube plus y square minus 2 into y minus 1. I've replaced 1 with y, so I get 2 plus 1 minus 2 minus 1. And here the terms cancel each other out as well, implying that y minus 1 is also a factor. So two factors that we have so far are y plus 1 and y minus 1. To get the third factor is pretty simple. I have here y plus 1 into y minus 1 into another polynomial, call it g of y, is equal to p of y. Now opening the brackets here, I get y square plus y minus y minus 1 whole into g of y is equal to p of y. This gives me y square minus 1 into g of y is p of y, which in this case is the polynomial given in the question, 2y cube plus y square minus 2y minus 1. Now I can do the long division method to divide the polynomial p of y with y square minus 1, and since we know that g of y is the factor, we can get our answer. Again, I won't be showing the long division in this question over here. You can refer to the previous exercises to know how it's done. But the solution over here that we will get is y square minus 1 multiplied by 2y plus 1 gives us the polynomial 2y cube plus y square minus 2y minus 1. And hence the factorization for this can be written as 2y plus 1 multiplied by y plus 1 into y minus 1. And that's the solution for the fourth part. That brings us to the end of this exercise. Thank you for watching this video. In case of any questions, comments, or requests, you can leave a comment below or reach out to me on the email ID mentioned in the description. I'll be back with future videos of the rest of the exercises.